We learned about the difference between how ionic bonds form with respect to their Lewis structures and covalent bonds. So ionic bonds are the result of a transfer of electrons and then having oppositely charged ions that are held together through a Coulombic attraction in an ionic lattice. Covalent molecules are just a sharing of electrons, and now we're going to show how that happens. So all atoms want to complete the octet rule, where they complete their outer valence shell. That was a little redundant by statement, but you know what I mean. So they all have 8 electrons in their outer shell at the end of the day, with the exception of hydrogen and helium, which only require 2 to be happy and complete. So that determines how many bonds they're going to form. For example, since hydrogen has 1 electron and it only needs 2, hydrogen will form 1 bond. Carbon has 4, needs 4 more, gotta form 4 bonds. Nitrogen has 5 valence electrons, leaving it needing 3 to complete its octet rule, so it forms 3 bonds typically. Oxygen needs 2, and fluorine, chlorine, and the other halogens need 1. And that will determine what kind of structures they form when they combine to make molecules. So the first molecule I have up here on the board is formaldehyde. It's just 1 carbon, 2 hydrogens, and an oxygen. And you can see that the carbon, which has 4 lonely electrons, and no electrons want to be lonely, has more lonely electrons than any of the other atoms. Carbon having 4, oxygen having a total of 6 electrons with 2 available to bond, and each hydrogen having 1 electron available to bond. You can see that putting them together in this fashion results in carbon having a complete 8 electrons in its outer shell, hydrogen each having 2, and then the oxygen having 8. So now we've completed our octet rule for each of these atoms. One other thing I want to point out is that hydrogens are always terminal atoms, meaning they're never going to be attached to more than one thing, so therefore they end up on the outside. I also tend to circle the unshared pairs as they don't form bonds. And if you don't do that, what ends up happening a lot of times is people draw them too far apart, and then they end up attaching to them to things and making mistakes. So we don't do that. And the final structure that we would end up with shows a double bond, meaning a sharing of 4 electrons between the carbon and the oxygen, and a single bond between each hydrogen and the carbon. The next molecule I'm going to have you draw right here is C2H2. What we have is each carbon has 4 electrons. Again, you draw them separately. And then the hydrogen only has 1. So what we can do is we can pair up the carbons where we put 3 of the pairs together and we form a triple bond between the carbon atoms. Then you have a single bond that would form between the hydrogen in each carbon, and you end up with this for a final structure. Again, hydrogen only needing 2. Each carbon has 8 electrons between it and anything else, so therefore it's happy. The next molecule I'm going to have you draw is ethanol, which is CH3CH2OH, which you could condense to the formula of C2H6O. But giving this kind of structural information tells you something about how everything's going to be put together. Since we know hydrogen's on the end and carbon likes to form 4 bonds, if carbon is bonded to 3 hydrogen atoms, it's also going to have to be bonded to the next carbon atom. So when we draw it out, that carbon should have 3 hydrogens around it. The next carbon has 2 hydrogens around it, so put 2 hydrogens around it. And then, obviously, carbon would need to be bonded to one more thing, so oxygen and then the hydrogen. So this gives us structural information that leads us to the molecule of ethanol, which is an isomer of dimethyl ether, which would have the structural formula of this. Both C2H6O. This one, however, you can see obviously it's arranged differently. Molecules have completely different properties, and that results from their arrangement of atoms in the order, which we can get from a more detailed structural formula. The last molecule I'm going to show you in this video is carbon monoxide. So this is a unique type of bonding situation where you have a coordinate covalent bond. If you try to draw the Lewis structure for it, you're going to recognize that, well, while oxygen gets its octet rule satisfied, the carbon wouldn't. So what ends up happening is you have one of the unshared pairs of electrons on the oxygen basically dumping in and forming an additional bond. Therefore, we now have a triple bond between the carbon and the oxygen. the other two lonely electrons end up just pairing up, and you end up with triple bond carbon and oxygen. Coordinate covalent bonds contain a bond where both of the electrons in the bond come from one atom. Most all of the other bonds that we've drawn here show one electron from each. So that's how they're different. This is kind of like, if nothing else works, go for it. And it happens in a few other molecules, including ozone, which I'm going to ask you to draw for homework. But this is a general intro to how we're going to draw Lewis structures for covalent molecules. In the next video, I'm going to show you how to draw exceptions to the octet rule.